Improper integrals part 2. Physics. Sure. Axis, that axis, I don't know. Is that thing you got going in your pocket?
Because he always marks us off points on the test if we don't leave our axes.
That should be a little more tricky. Even just the x and y axis, if you don't label your x, it's just the x and y axis, you gotta label that?
Every axis.
And yet he's okay with improper intervals? That's ridiculous. Okay, here we go. What did you get for an answer? Andrew, what did you get, dude? You got one. I got one too. Do we all agree with one? Which obviously implies it converged, yes? Okay. Now, today's lesson, we kind of touched on this a little yesterday. We'll go through a little more detail here. If you did the same curve, but instead you shaded this tail of the curve, it has symmetry across y equals x, and therefore it should be the same. Now, if we find this area using x as the variable of integration, I shouldn't have shaded that like that. No, shucks. Then don't my rectangles still go up and down if they're x-ish, yay? So what are the bounds from an integral? 0 to
1.
1. Yes, when y equals 1, x would equal 1. Cool. Now that doesn't feel improper. This not improper? Question mark. But what is the integrand? Upper minus lower? No. 1 over x squared minus 1. Yay? Okay. Now, although it doesn't feel like improper, it is improper because of the 1 over 0 discontinuity kind of thing. That function is not continuous over that interval. And so to do this properly, you would have to create this kind of edge, A, and let A go to 0 from the right or above, if you like. What are the bounds then?
From
A to 1. Now I just gotta know. I assume this is going to be the same, but I gotta see. I'm a doubting kind of guy. What is the antiderivative? 1 over x, or 1 over negative x, minus x from A to 1, yay. That's the limit as A goes to infinity of, when 1 goes in, I get 0 minus, oh, thanks, pal. Okay, I thought you meant these parentheses. They don't go to 0, they go to negative 1 minus 1, or
Negative 2.
negative 2. I didn't expect that. When A goes in, I get negative 1 over A minus A. Seems like I'm doing something wrong, but okay, well, trust the process. Here it goes. So, oh, well, this is unfortunate. What happens as A goes to 0 then? Is there symmetry? Maybe they're not the same.
-1 outside.
You could do -1 outside, but I didn't, so let's deal with it. So, -2 minus when A goes in. As A goes to 0, what does -1 over A go to?
1.
Infinity, yes? Maybe there's not symmetry to these curves. And minus 0, yeah? So this, of course there's not symmetry. It's a square root versus a square. That's not going to be the same. So this shape is different. This actually diverges. These are not the same. Sorry, I lied to you. Now I feel foolish. Shame, shame. All right, you with me? All right, now then, there are two types of improper integrals. The one we've already talked about since 125 is when it's totally obvious you've got some funny business going on. There's an infinite limit there. The less obvious now will be when it looks normal, you've got a number and a number, but if you look or think about the continuity, for example, if you went from A to B, but there was a asymptote at the left endpoint A, then you'd have to do a limit as some number approached A from above, yeah? Are you with me? Okay? Likewise, you could have a discontinuity at a right endpoint. Maybe it goes from A to B, but there's a discontinuity at the right side, in which case you create a constant and approach the right end from below. You follow me?
Yes.
And the worst possible case is it feels like you have a normal old integral. It's continuous at A, continuous at B, but doggone it, there's some asymptote right down the middle, in which case you need to do not one limit, but two. You might create a K to approach that C from below. K is arbitrary, use whatever you want. And a J to approach from above, and you'd have to do two limits. These limits cannot usually be combined. Talk about that later. They're different. All right, now, your life now is much harder. As a BC Calculus student, it's even harder than a Cal 2 student because your BC exam will consist of Calc 1 and Calc 2 questions. And you might have something like this on the AP test, and it's just a -1 to 1 of x squared. There is no monkey business, there is no limit, there's no fancy, you just freaking integrate it and you do your fundamental theorem of calculus thing, yay? And yet, on the next question, it might be this. In which case, if you just try mindlessly plugging and plugging, you're going to die. It's got a huge discontinuity right down the middle, yay?
Yep.
So now you need to first and foremost say Calc 1 or Calc 2, continuous or not. If you mindlessly crank out this, for example, without checking, hey, that's discontinuous at 0, this is from experience, you might just say, hey, is calculator active? I don't even need to integrate it by hand, and I would get people saying 1.782. First of all, are you so lazy you can't move your little eyeballs one little micro inch, whatever, over? Okay? It's infinite. You need to pay attention to discontinuities. Understood? Okay, so let's practice one or two, shall we? This guy, we're going to check continuity. Is it continuous? No, so let's deal with the discontinuity at 0. Let's let, what do you want to let? Limit as A goes to 0 from
Right.
to the right. From what to what?
A to 4.
A to 4, and I personally would probably rewrite while I'm doing it, I'd probably rewrite it as a power, so I am less likely to screw up the integral. Okay, you with me?
Yep.
Okay, the antiderivative for which is 2 root x. I concur. From A to 4. Fundamental theorem comes next. Typically you do these in 4 steps. So limit, rewrite, an antiderivative, a fundamental theorem, and then an evaluate. So when 4 goes in, I get 4, and when A goes in, I get 2 today. As A goes to 0, this integral converges to
4.
All right? Try one on your own. Integration technique for you, huh? What did you say for the antiderivative? Log of eating x minus 1, yeah. Okay, getting there? Okay. We agree until we get to the fundamental theorem step, natural log of e to the a minus 1 minus natural log of e to the negative 1 minus 1?
Yep.
Okay. What is the first one approach? Negative infinity. E to the a approaches 0, or 1 rather, excuse me. 1 minus 1 approaches 0. Log of approaching 0 is negative infinity. I agree. Should I bail and say divergent?
No.
You should not. Sometimes it is the case that they're both diverging and you can combine them via log rules. So let's soldier on. What does the second one go to? It's finite. Do you agree?
Yeah.
Okay, so infinite minus finite, is that indeterminate or I know? I know. What is it? It is negative infinity, so we would conclude divergence, yeah? Alright, are you with me? Okay. Let's go with a middle split kind of thing. Where's the vertical asymptote for this bad boy? 1. So because I have an asymptote at 1, I am going to need to do a 2 limit case, 1 from below, 1 from above. So let's let the lower one be A and the upper one be B. Give me your first limit statement. The limit as
A approaches 1.
A approaches 1 from the left of the integral from
0 to
0 to
A.
A.
0 to A of 1 over x minus 1 dx plus
Because B approaches 1 from
of an integral from b to 4 of 1 over x minus 1 dx. Okay?
Yeah.
Okie dokie. Much as I would like to say, okay, there you go, you're good, let's continue on because the whole process is a little confusing. I want to practice the whole improper process. So the antiderivative, I think you'll agree, is log of the absolute value of x minus 1. Yay? Okay, cool. The limit as a goes to 1 from below, log of a minus 1 minus log of absolute value of negative 1. Yay? Pretty cool. Plus the limit as b goes to 1 from above of natural log of 4 minus 1 minus log of b minus 1. Cool? Cool. All right then. What about the first one? As a goes to 1, a minus 1 goes to 0, and log of 0 approaches negative infinity. Minus log of 1 is just 0, yay? Okay, cool. That's unfortunate. Let's continue on. Log of 3 minus, what about log of b minus 1? Where does it approach? So that's minus negative infinity, yeah? So I get negative infinity plus infinity, that is negative infinity plus infinity is indeterminate. And those limits, because these limits are different, those cannot be combined because different limits combining for more info is not possible. More is not possible. So we basically just stop and say indeterminate. And it's hard, it really would depend on how fast A and B approach 0, or 1, excuse me. You down? Okay, cool. How about example, whatever that next one is? What would you do first? Factor to the bottom. Cool. How does it factor?
Never mind.
That's what I say. I don't know. Okay. What do we need to investigate? We need to know if there's a 0 there, yeah? And not so much do I care if there's a 0, but if that 0 is in negative 1 to 0, I need to see if this is improper, right? Are you with me?
Yep.
Okay, so what is the 0 of that?
Surprise.
4, 1, 2. Real or not?
No,
Not real, non-real. What does that imply then?
doesn't exist.
We're fine.
No real zeros. What does that imply about the graph of this function? It has no vertical asymptotes. It has no vertical asymptotes. So is this a Calc 1 or a Calc 2 problem?
Have fun.
It's Calc 1. Now it's an advanced Calc 1 problem because you can't really be a total knucklehead and integrate this. You have to be on your integration game. That is part of this is a Calc 1 quick review. How would you integrate that, my friend?
So you take x squared plus 2x and you multiply also x squared plus 2x plus 1 plus 2 minus 1.
Okay, so I believe that he is saying you're going to complete the square and go for arcane.
Oh, okay. Yeah.
Okay.
Yeah.
So, whether you break up the 2 into 1 and 1, or you stash the 2 and complete the square, it'll come out the same. I don't know how would you proceed? I'm telling you, complete the square now. You tell me what to do. Would you break 2 into 1 and 1? Or would you put the 2 off to the side and just complete the square like normal? Whatever. You would, either way, you would get the same thing, and that is the square of x plus 1 plus 1. Wait. Now, I hope you don't need to use sub this. You will just see that the antiderivative is arctangent of what? X plus 1 from negative 1 to 0. What is arctangent of 0 plus 1? Arctangent of 1 is pi over 4 minus arctangent of negative 1 plus 1, or 0, which is 0. So our answer there would be pi over 4. Wait. Okay, just thought we could use a little practice. All right, last but not least. Not last, but I don't know why I said that. That's nowhere close to being done. Sorry, keep going. What's the next one? What would you do? Factor. It does factor, and factoring makes it a little more obvious where the asymptote is. This definitely has a discontinuity at negative 1. So this is a left endpoint kind of case. So give me the limit statement, the limit as. It goes to negative 1 from the left, right? Right. Of negative 1 to 0 of x plus 1 to the negative second, yay? What is the antiderivative?
A,
0 to a, yes, my bad.
A to 0.
Yep, good call, thank you. Yep. What's the antiderivative of x plus 1 to the negative second?
Negative 1 over
Negative 1 over x plus 1 from a to 0. Bene, limit as a approaches negative 1 from above of negative 1 over 1 plus 1 over a plus 1. Oui, oui. Oui. And as a goes to negative 1, the denominator approaches. Tell me if it would be infinity or negative infinity. A little more than negative 1, so will a plus 1 be positive small or negative small? Positive small. 1 over positive small is? Positive large. I don't know if a multiple choice would just say diverges or if it would have infinite as a case. I'll have to look that up, but it would be positive, infinite, and therefore divergent. Okay? Are we cool? All right. Terrible amount of writing case is case like that. Why is that problematic? Oh, yes. By the way, there's also triple trouble. You can also have triple trouble. But that's for later on. Should we go triple trouble?
No.
We can change it to triple trouble. Let's change it to triple. Let's change it to triple trouble, but just set it up, okay? So change that to negative 1. And tell me what do I got to do? Three. Ergo the name, triple trouble. Limit as a goes to 0 from the left from
negative 1 to 0.
Okay, so let's talk the graph. Would you agree the graph has an asymptote 0? Oh, yes. And I'm going from negative 1 to infinity. So first of all, I need to create a left edge just before 0. Yay?
Yes.
Right. Then I'll need to, what else?
Create another ledge right next to it.
Another right edge on the right of 0. And then I'll also have to create a C going to infinity. We? So here we go. The limit as a goes to 0 from the left of negative 1 to a plus the limit as
B goes to 0 from the right.
goes to 0 from the right of
B to C.
B to C, and the limit as C goes to, oh, no, you might have to do 4.
Why don't you just put it to a random number in that spot?
Can we just say C is 4?
Yeah.
No, can
Okay.
we do the limit as?
We will need 4. I like 4. Cool. I'm down. Because we can't have B and C both unknown.
Yeah.
Default.
Why can't we do the limit as B goes to, of the limit of C goes to?
Oh, limit of a limit?
Yeah.
That's not a thing.
That does not sound good.
Now you're making up numbers. That's not. See, not even in multivariate. What?
Here in our high school
You can do one.
calculus
Yes, this is
class.
arbitrary. Some arbitrary middle point.
Yay. Yay, 4.
Okay, 1.
Four's
Everybody
good.
gets
Four's
4.
good.
Let's go to pi.
What?
Let's go to pi e squared.
No.
Well, he just
It's
said.
arbitrary.
What? This is like
It's arbitrary.
Why would you choose a bad number
Why
for an
not?
arbitrary number?
You're not going to evaluate it.
Yeah.
And so, boom.
Huh. Yeah, 4.
Okay. And there we go. Are you with me? You can do whatever letters you want there, as long as it's logical. Are you with me?
Did you say he had 4?
I misspoke. I don't know. Okay. All right. Are we cool?
Yes.
Is that it?
Jeff?
Just careful declaring conversion.
Oh, yes. This was an issue one year in the AP test. It's pretty rare, but I don't, at this level, you guys, we prepare you for every possible little thing. Shoot, where's 130? Sorry. Is this 131?
131.
Excuse me. Okay, so here we go. There we go. Boom. Okay. Last but not least. Okay. This guy. When you go to create the middle cut, the limit as A goes to 0 from below, from -2 to A. And then an uppercut from B going to 0 from above, from B to 2. Are you with me? Okay. So when you anti-differentiate here, this is going to be a diverging kind of case that there's no remedy, like we talked about a little earlier. Should have put that in favor, so I didn't have to do this. Sorry, I assume you're doing fine, yeah? Okay, log of A minus log of 2.
It goes to 0.
Log of 2 minus log of B. Alright. Integrate limits, integrate fundamental theorem, and here we go evaluating. I think you'll agree that log of A goes to infinity and negative log of 2 does not
Goes to
change.
negative infinity.
It does.
Limit as A goes to 0.
From 0, negative infinity. Thank you, big call. Okay. Negative infinity, and then this guy goes to minus negative infinity, so positive infinity, and this is those cases that because the limits are different, it is indeterminate, and you're done. That's all you can do. No combining to be done. Like the one a little earlier. You follow me? Okay. It is, however, tempting then the minute you get an infinite to bail, and that can be disastrous. So in a case like this, for example, first of all, check interior continuity. Are we cool with continuity? We are. So here we go, integrate or setting up a limit just for the infinite part of this, 1 to A. Are you cool? Okay. Now, when you go through this anti-differentiate, you you will see some of that same infinite behavior.
But they're the same infinity.
Yes, you'll have the same kind of limit, I think, if I set this up, though, if I made this problem now. So do you get something like log of a minus log of a plus 1 when a goes in? And log of 1 minus log of 2 when 1 goes in, yay? Now this is infinite minus infinite, but that's not indeterminate, because we can do something. What could we have done here?
They're the same infinity.
Yeah, you could have used limit rules here. There's more to do. Log of a over a plus 1, yay? Well, that's what's going on here. So log of a over a plus 1 minus 0 plus log 2 at the back end. You see where I'm coming from? Okay, what about a over a plus 1? What is the approach? Approach is 1. The log of 1 approach is 0. 0 minus 0 plus log 2. This is not indeterminate. It is convergent to log 2 in this case. That's true. We could have done it in a telescoping kind of way. Good call. Yes, that's true. It looks telescoping. Probably does converge too. Okay, that's the end of that story. How'd that go? Okay, just getting you, how did, about 5 minutes here. This one, did you, or which ones would you like to talk about?
10, 12,
10,
12,
12,
14, 3, 14,
10, 12, 14, 3,
14's
8.
telescoping.
Okay, so I can give you some quick pointers that'll get you started and you can finish these. 10, I would strongly recommend the integral test. Did you try the integral test? It works very well.
Oh, yes.
Okay, so try the integral test. 12, this is a little harder.
Is it a root test?
Use, I did not use the root test, use a direct comparison test. Now, you want to compare it to roughly, did I? No, I showed it to somebody, I didn't close it, we were on all together. Okay, roughly compare it to the biggest power over the biggest power. So you're shooting to compare it to 1 over root n, you with me? Getting you started with the inequality, I would start here. N minus 3 is greater than n. Starting basically with the extra nonsense. You with me?
It's less than n.
It's less than n. Yes, you're right. It is less than n. Very cool. Then gradually build out the other stuff. I think you'll agree that this has a root n in it. So you would bring in other stuff, doing the same to both sides. And you would take reciprocals and series, and I think you'll see a conclusive test. Alright, that should go well, that should get you started, continue on down. Can I go to 14? Okay, 14 is, there's 14. Okay, this is telescoping. You should start by decomposing it. Then it'll go well. I think it converges to, what did I say? It converges to 1. At least that's what I got. Okay? 3. Does anybody need a little help getting started on 3? Okay, 3 is also comparison test. This is your starting point. Natural log of n is less than the square root. Now you want to build this out. So to get this, what should we do to both sides? To get that, we need to divide both sides by n cubed, which is mathematically sound, yeah? Now, that said, this is the same as 1 over n to what power? N square rooted over n cubed is 1 over n to the 7 halves or 5 halves? 5 halves. So the series natural log of n over n cubed must be less than the series 1 over n to the 5 halves, which is converging or diverging? Converging p-series. So less than converging is conclusively converging. That should get you going down. Start with an accepted fact and build out to what you want to get. And then 8. There you go to 8. 8 is also a humdinger. Again, focus on the dominant terms. So you're going to compare to 1 over n to the 3 halves is the best way to go. I didn't want to integrate that, and this is the first thing I saw. Let me know if you had some other alternative. In terms of getting there, I would start with, how does this compare to nothing at all? Well, assuming n starts at 1, isn't n squared greater than nothing?
Oh, yes.
And therefore, n cubed plus n squared is greater than n cubed plus 0. If you add n cubed to both sides. You follow me? All right. And then continue on building out towards that. So bring in the root, take the reciprocal, and switch some.
Can't you just start at the second one?
Start at the second one. I suppose that's fairly obvious. I guess that's acceptable. Okay. Does that get you started? All right. Can I get these by the end of the day then, after you make your fixes? Have a lovely day. Buenos dias.
I got
I
it.
never closed the ski for it. Is that a problem? You did? I didn't post the key. I apologize. I will look it over myself. Yeah. Yes. Sure. I'm happy to help you practice if you need more practice on anything going 7.
Jim looks over at my
I don't know if I'm meeting after school.
Okay. Stop this recording. Hi, people watching this.